Hello, this is Jeff Lepp with the Fort Bend Astronomy Club, and in this video I'm going to be demonstrating how to do live stacking in SharpCap. Live stacking is a way to generate images of deep sky objects relatively easily without the complexities that you run into with astrophotography processing programs, as those are very complex. To start out with SharpCap, I can select an actual camera, or I can select a folder that has previously saved off images in it, which is quite useful if we want to practice, let's say, or process data that we've taken after the fact. So I can select the folder monitor camera option here, which will prompt me to select a folder. I have some data out here in my M33 directory, which is the triangle galaxy that we've previously captured on our club's 18-inch Newtonian that is housed at the George Observatory. This data is 10-second exposures taken at 120 gain and 5 degrees Celsius. To select the folder, you have to actually click on a file, and then this All Fits File button shows up here at the bottom. If you don't do that, you won't be able to open the folder, and that's because it's wanting you to select the file type that it's going to be filtering on. And we choose the Fits file type because that is the pretty much standard format for most astrophotography and processing programs. That gives you a little bit better depth and resolution than the standard PNG format that SharpCap defaults to. So I click on a file and click on All Fits, and it will then open up that folder and it will load the first file. But it's dark because it's still in its raw or native format, which is called linear, and we have to what's called stretch the image in order to be able to see the detail that's in that image. Before we do that, I'm going to show you another option that's very important that could get you stumped. There's this debayer preview option, and we're using a color camera, specifically a ZWO ASI 294, and all color cameras have these little filters, a little filter over each pixel. So we have a red, a green, or blue filter, and there's a pattern to it. And in order for it to take that information and make a color image out of it, it needs to know what that pattern is. And when we're using the camera, when we connect to the camera, it can figure that out on its own, but when we're playing back the data, we have to actually tell it the pattern. And in this case, it's RGGB, red, green, green, blue. If you don't know what your pattern is, you can do trial and error here. A lot of times you just look it up on the internet. If you turn it off, it's going to be a black and white image, so we want to make sure that we do select a debayer preview on this. Back to the linear image. So we see it's mostly black, and you can see some little smudges or white dots here. Those are actually stars, the brighter part of the image. And this is a raw format that the computer uses, but in order for us humans to actually see it, we have to translate this into a display format that we can see. So when we talk about stretching the image here, we're not actually permanently stretching it. We're just creating a screen representation of the data that we can see, but in reality it's still internally kept in its raw format. So to see that, we can click on this little lightning bolt, or what I like to call the Shazam icon, to auto stretch it. And when we do that, we can see that, okay, now we know what the object is. It's a galaxy. We can see that, but it has this green background or bias to it. And that has to do with the fact that the camera is sensitive to green. It's got more green filters than it does the other ones, but it's also very sensitive to the green spectrum. We're going to take care of that when we do the live stacking. There's not a way to color balance it using this little histogram here, but the live stacking allows us to do the color balancing, so we're going to wait till then to do that. To do the live stacking, you can see we have this little play button to start the playback, and we have this live stacking button up here to start the live stack. But there are two files I want to first load. I want to correct these images for for some issues, for hot pixels and for vignetting. And the best way to show that to you is to actually show you these calibration frames that I'm going to load here. These are darks and flats that we're taking ahead of time in Tools and SharpCap, and I'm not going to get into that in this video. That's more advanced from what I'm trying to show here, but these files were created ahead of time, so I'm going to go ahead and use them. And I have other software that I call PixInsight that I'm going to show you what those look like. So switching over to PixInsight, I've loaded the master dark and master flat frames. Now these are masters in the sense that they're not an individual frame that was taken. They're actually combination or averages of calibration frames that we took. The left one's the dark, and so basically that frame is taken at the same exposure, the same gain, and the same temperature as the light frames, or the target that we're imaging. We'll call that the light frames. And the reason why we take those is to correct for hot pixels, which you can see as the little white dots that show up, and amp glow, which is a feature of this CMOS chip. The longer the exposure is, the more these rays and this glow appears here. We're using relatively short exposures, so it doesn't really affect us that much for what we're doing, but if we're taking longer exposures it could become a problem. And the dark correction takes care of that for us. The flat, as you can see here, this is an evenly illuminated image. In other words, we're trying to take a picture of a white light source where the illumination is even across the image. And we're not exactly getting that, but we want the average to be the middle point of the histogram. But the edges are dark, so that's called vignetting. And if we didn't correct for flats, what would happen would be the background of our image that we're creating, the stack that we're creating, would be brighter, just as in this flat, would be brighter than the edges. And so to correct for that, we take this flat and we then correct the image with that. So how does the correction work? The darks are actually subtracted from each image. The master dark is subtracted from each image, so that the hot pixel gets subtracted and the amp glow gets subtracted out. The flats are divided into each image, so that what happens is we're actually doing a pixel by pixel math operation. So when we say subtract or we say divide, we're actually pixel by pixel between each image, we're actually subtracting or we're dividing that pixel from the calibration frame either into or out of the light image. So in this case, this corner pixel here, we would divide that into the light frame, so it would brighten that corner up. So the effect would be it would brighten the corner of our final image. Likewise, the bright dot or hot pixel gets subtracted from the image the light frame that we're using to build our final image. So that's how that process worked. I just wanted to show you what those frames actually look like, because most people think it's just magic that's happening, and so there's actually a mathematical process that takes place when we apply these calibration frames to our actual light frames or image frames that we're taking. So I'm going to switch back to SharpCap. Back in SharpCap, we can now apply these frames to SharpCap, and we want to apply these frames before we start the live stacking. If we apply them after, we then have to pause and reset the live stack and restart it for the calibration frames to take effect. So it's very important. It's easy to forget to apply these ahead of time. I do it all the time. So I'm going to come in here and I'm going to go to the folder that I've got my calibration frames in. So these again were taken with SharpCap, and I'm going to select my master. So this is my master dark, and I'm going to select my master flat. So now they've been applied. So now I'm pretty much ready to start the live stacking process. But I don't want to start it with this histogram here stretched. The live stacking will have its own histogram, and if I have this stretched to its max, it's going to affect the live stacking histogram. So that also stumps people that are first starting out with SharpCap, is they forget they left this auto stretched and then they start trying to use the live stacking histogram and they're not going to get very far. So Start out by resetting, if we've stretched this, reset it back to its linear state. Then we're going to click on the Live Stack toolbar button up here at the top. Okay. And then we're going to click on the play button. And when we click on the play button, we're going to play it back at 1 frame every 8 seconds to kind of simulate as if we were doing it live with a camera. I don't have a 10-second option here, so 8 seconds is close to 10 seconds I can get. So as soon as I hit the play button, we start playing these guys back. And we start to see our image getting built here, and we can see it's still kind of green as it was when we did the auto stretch with the little histogram. And I'm going to set this back to the default states just to show you here. Okay, this is the default state it's going to appear in. If we use the auto stretch and the auto color balance, the auto stretch doesn't do too bad of a job, but the color balance just doesn't help out. It actually kind of makes it worse. So we can set it back and do whatever. So we change that by adjusting these sliders and these bars. So the first thing I'm going to do is I'm going to take this white balance, which does nothing but blow things out, all the way to the right. There's no need to make the bright stuff more bright. So I just move that all the way to the right. Then what I'm going to do is I'm going to adjust the colors by sliding. Let me go ahead and do that. That's a little bit better actually. Let me go ahead and do that by sliding this thumbnail up and down. So I'm going to take the green thumbnail and slide it down, and it's really easy to overshoot this. So what you can do for fine-tuning is you can actually click above it or click below the thumbnail, and it actually does it in small increments so that it will allow you to do a finer touch than if you were sliding the thumbnail up and down, because it's really easy to overshoot. So if you wanted to go down in the red, let's say 1, we could go down the red by 1 like clicking on it. So there we go. So the sliders over here, or the bars over here, they kind of do the actual stretching. And we deal with this black level and this mid level. The black level allows us to improve the contrast. If we go too far with it, it actually starts what we call clipping the background. It actually makes it black. And if you keep going too far, we start destroying the galaxy itself. That's not a very pretty picture. So what we want to do is we generally want to keep the black level, or what I call black point, just to the left of the hump. The histogram hump here. And so I am going to then adjust the mid-level or mid-tones, which affects the overall stretching of the image. So we can see where we move it to left, it stretches it, we move it to right, it goes back to its linear state. So I'm going to move it to a point that looks fairly reasonable. Probably black clipping a little bit too much here, so let's go ahead and move that over there. It's still pretty bright, the background, but we can adjust that here in a little bit. I'll show you how to use the small histogram, but the color's still a little off. The green was a little high on there. So now we're getting closer. The little histogram is actually used for fine-tuning, so you can think of the live stack or the big histogram as the coarse histogram, and the small histogram is for fine-tuning operations. And we can do the same thing that we did with the big histogram regarding the black level and the mid level. That is, we want to take the black level here. Let me move it up so we can see it better. The black level, and we can scoot it to the right to increase the contrast. So now our contrast is even better. And then we can take the midtones and we can move it over to increase the brightness. So, and you can also, if you need to go back and make a small adjustment here, you can also make a small adjustment here. And they kind of interact with each other, but one is kind of coarse and the other one is kind of fine. So that's the way that I think of it, and that's the way it seems to work out well. So we've currently stacked 29 frames. And we've ignored some. The reason why we ignored some is we have a filter set. So let me just discuss that. So here we have this FWHM filter. And what that stands for is full width at half maximum. It's a mathematical formula that measures the profile of a star. What does that mean? Well, in layman's terms, that is the fatness of a star. How fat is the star compared to, it's a measurement of that, and you compare it to other measurements you take with other frames. And the higher it is, the worse it is. So what we do is we come up with a maximum value, we reject the frames that are above that value, and we accept the frames that are below that value. And so that's why we've rejected some frames. So we want to make our image better by kicking out the ones that have a worse star profile. And why do we have that? And that's because tracking glitches, the mount that we have is 28 years old, so it has some tracking problems occasionally, so we want to kick out the bad frames there. So that's a fairly useful tool to use that we use all the time. You can also, if you want to minimize this stacking window, there's a little pin here you can click on, and then it blows this image up. If we want to zoom in, we can maybe go to 50%. We can zoom in and see some of the detail that we're getting here. We still got some noise, because as we stack more, the noise reduces. We can, now that we're doing this, we can speed up the stacking process here. We've got 121 frames to stack. We've only stacked 15. We'll keep going up. But as we stack more, the noise gets reduced. And that is a function of the square root of the number of images that we're going to stack. That's called the signal to noise ratio. So the signal to noise ratio improves by the square root of 121 here, or actually not 121, but the number that actually don't get rejected, which will be probably around 100. So at 100 frames, we're going to get an improved signal to noise ratio of 10 times over a single frame is what we're looking at. So you can see the dust structure here in the galaxy is starting to become more visible. We can see the arms of the galaxy, and these reddish or pinkish areas are actually the Emission Nebula in that galaxy. So those are areas generally where stars are being born, similar to our Orion Nebula, that we can actually see in this other galaxy. So that's pretty cool. So I'll go back to my auto here so we can see the whole galaxy in its entirety, and we've already stacked up to 104, getting closer to the final count. To bring the live stacking window back, we can click on it, and then we can pin it back. And once we're actually done stacking this image, we can save it off. There is the save button here. We can click the little down arrow, and there's several save modes. If you want to save it off to email it or post it on your website or Facebook or whatever, you can do save exactly as seen, and it will actually save it in a PNG file format exactly as you see it on the screen. And that's useful for immediately, sharing the image with somebody. The save as 16-bit stack allows us to save it in a format that we can process it further with other post-processing software like Photoshop or PixInsight. So that's what it would still save it in its raw, unstretched format, so you have to go through the process of stretching it and so forth. But that's if you want to do some fancy post-processing on the image. But if you're just trying to get an image to share with people, the save exactly as seen is what you want to use for that. So this has been a fairly short run through. I didn't want to necessarily give you the grand tour, but basically just what you need to know to get up and running with SharpCap as quickly as possible, and basically go over the process of adjusting the histograms. Both the coarse and the fine histograms is an important concept that until you understand the relationship between these two histograms, you'll get really confused. I hope that this video has been helpful, and thanks for watching. Real quick addendum here. When I went back and reviewed my video, I noticed that I had covered up the selection of the darks and the flats with my video display. So I just wanted to cover that real quick. To select the darks and flats is under this processing section under the camera panel, and you just hit the browse button, and then you just browse over to your folder where you have your calibration frames at, and then you just select them that way by hitting the browse button. on that. So just wanted to do this quick addendum to show you how that's done, since I had it covered up, and I apologize for that. Thanks.